G'day and welcome to Cloud Cartographer. Today I wanted to talk about Ingress resources. So out in the field I get asked a lot about exposing services in Kubernetes externally, and there seems to be a lot of confusion and a little bit of lack of understanding out there as to what Ingress resources are and how they work. So just high level, Ingresses are essentially reverse proxies that are configurable in a Kubernetes native way. So how ingresses work is there's an ingress controller, which would typically be an Nginx, a HA proxy, or a custom built web server that can handle the requests that are put in via ingresses. So basically you create this controller and it listens on the ingresses API in the Kubernetes API for the request for ingress resources, and it needs to be able to fulfill those. And that's just typical reverse proxy stuff there. Paths, setting up paths and different rules as to how to route traffic into your cluster. So one thing that I saw this week that I thought would make a really slick little demo is in the Kubernetes charts repo. There was a developer out there who submitted a Traefik chart, and this is an implementation of the Traefik HTTP reverse proxy using Helm. Now that was exciting for me, but the best part of this is it's also integrated into the Kubernetes API natively, which is out of the box with Traefik, and it also talks to Let's Encrypt. So I thought I could put together a nice little demo of how that all might fit together. So really what I wanted to show was creating an ingress controller and then laying down a request for an ingress resource and getting that fulfilled by the ingress controller and having traffic route to that. So let's jump into the demo here. If I do a helm status on my Traefik release, you can see that I actually have here a couple of resources already created. So I went ahead and created the base installation here. So we have a config map, we've created a dashboard resource and a traffic service there that's exposed externally. So that's obviously where you would point all your DNS records to that external IP or load balancer in this case. I'm on AWS. There's a deployment and there's an ingress already there for the dashboard. So just in the interest of time here, I wanted to show you spinning something up fairly quickly. But I'll go through adding a new one. We have the ingress there and we have a persistent volume claim. So remember I said this can go out to Let's Encrypt via Acme and request certificates on the fly. So this is out there and running right now. The UI is here and obviously the dashboard's up and running. So there's a service on cluster that's running the ingress controller, and the dashboard ingress is allowing me access to that. So this is up and running right now. I have another little app on the Kubernetes cluster. It's called Croc Hunter, and Croc Hunter has a service, and I want to expose this via that ingress controller. So I can say, please give me Croc Hunter externally via that ingress. So how I would go about doing that with Helm is, we'll go and take a look here. So I have the Helm chart opened up here, and what I've done is added to the Helm chart another section to the values.yaml, another scope of variables. So I've created this Croc Hunter top level, and I'm going to set this to true, and I've configured the domain here. Obviously that's required for when I'm requesting and when the HTTP requests come in, and for Let's Encrypt. A service name, so that's the backend service on Kubernetes that I want to hit, and that is seen here, and the port that that service lives on. And this ingress controller is unscoped, so it looks on ingresses on all namespaces, so it should pick it up, and I'm going to provision that in Croc Hunter namespace because that's the namespace where my Croc Hunter app lives. So all I should do, all I've done right now is flipped false to true, and I can simply go back over here and perform an upgrade. So I'll do a Helm upgrade on Traefik, and all I've done is flip false to true. One thing I'll just pop over and show you, here's actually the ingress. So if this value is set to enabled, then render this Kubernetes manifest with those pre-filled values. So using Helm is a nice slick way, and I can put some links into how you can get your hands on Helm in this chart. So I'm going to submit that. Now the thing you'll see here is you won't see it because apparently I didn't save it. Yes, I did. Oh, here it is. The ingress. It was just in a different order. Had myself worried there for a second. So I've submitted this ingress, and I've asked for it at this name. So at this point, actually, let's go and take a look at the logs. You probably just see a hub. Yeah. So it's loaded it in. It's gone out to Acme to ask for a new certificate, out to Let's Encrypt. Let's Encrypt has delivered a certificate with the host name set, and it's put it on that provisioned that persistent volume, and has reloaded the actual Traefik ingress controller here. So if all this worked, I had this endpoint and sitting here ready to go, I should be able to hit this. Okay, fantastic. So let's go and take a look. So I should have a valid certificate, a Let's Encrypt certificate, and I'm actually hitting my backend application now. Fantastic. So I'll pop back over to the Traefik UI here, so you can see that I've provisioned this new service, and it's picked it up and it's routing it through to this service on the back end, which maps to what Kubernetes should be thinking if I was to add the endpoints to this command. Yeah, 10.2.4.16 on 8080. 10.2.4.16 8080. So as you can see, this is a really clean, slick way to be able to lay down an ingress controller using Helm, and then a really nice way to be able to provision services externally and have them provision SSL with a great service like Let's Encrypt via the Acme protocol. So you can see the power of what ingress controllers allow you to do. They're very flexible, and you could imagine a world where you had scoped ingress controllers. So you may have a dev Traefik instance and a prod, and they're looking at separate namespaces if you had services co-located within the same Kubernetes cluster. So you know, the call to action is I'd love to see an Nginx or a HA proxy Helm chart that kind of delivers the same functionality and wraps it up, because I think one of the barriers to entry with ingresses is actually getting an ingress controller installed, and from there just understanding what annotations you need on services for the controllers to be able to pick them up, or any special routing as such. But as you can see here, this is a very clean, lightweight way for us to roll something out and expose it externally via SSL when the backend service does not support SSL. So thanks for joining. I'll post some links, and I saw that Kelsey Hightower had a great little GitHub repo out there that was doing a similar thing on GKE, so I'll put that in there as fodder as well. But let me know what you think. Hopefully this was useful. Thanks for tuning in. Bye.